All right, welcome back. So yeah, this topic is pretty straightforward and easy, but to be honest, this is one of the most boring topics out there in the entire CS syllabus. If you guys enjoyed this part, the next topics are going to be more enjoying and fun. So yeah, where did we left? Okay, so this part is known as amplitude. What does a computer do? A computer basically gets to know what the amplitude of each wave is. It like I know the amplitude of this part is 1, the amplitude of this part is 9, the amplitude of this is 10, and let's say this is 12, which we remove later. Okay, this is 12. So a computer converts these amplitudes into binary form. So it gets to know the amplitude and then it converts it into binary. So, one other thing, now we are going to be discussing some very important terms which you guys need to memorize and are there in your course. Number one, sampling resolution. Sampling resolution or the bit depth. So, just a second, bit depth. So, basically, sampling resolution refers to the maximum amplitude which you guys could like possibly have. Let's say now in a scenario like this where I made this box from 0 to 10, we are ignoring this part, right? This 12 part, or let's say whatever this is. But on the other hand, if I have a top box which is something like this, which also covers the 12 element, wouldn't this make sure that the quality is much higher because we also have the 12 element in it? Obviously, it would. And so just because of that, a higher sampling resolution basically results in a much better quality. And so this amplitude is referred to as sampling resolution or bit depth. Sampling resolution or bit depth. And both of these terms are the same thing. They are known as, like, you could call sampling resolution bit depth. It's the same thing, no difference at all. But people usually confuse and they don't get what's the difference between the two. Never mind, leave that. We need to understand what they are. So these values 0 to 12, these are bit depths or sampling resolution. The higher they are, the higher they are, internet is a bit okay. Asad, you made this small of art up here. If you could remove this, I don't know, because it would come in the recording if you can. And so the higher they are, this resolution, the better the quality of the sound would be, the better the sound quality. No worries, no worries. The better the sound quality. And so if let's say there is a scenario where using as bit depth from 0 to 10, the quality might be okay. But if we are using 0 to 100, it would be best. Because from 0 to 100, we could have much larger waves like this, whereas in 0 to 10, our waves are only going to be like this. So that's the difference between why we have such different qualities. And usually in these what do we call it, sound files, we have stuff like 320 kbps and then 120 kbps. These refer to basically the sampling resolution and bit depth. How if in a 320 kbps the sampling resolution would be larger as compared to 121, because and due to that reason the sound quality would also be good. Now this quality won't be something which you guys might be able to recognize straightforward. Like let's say if you hear some sound at 320, it might be similar to 180 or 201. But if at a larger scale you analyze it properly, you would see the difference present. So sampling resolution basically refers to, now this is the exact definition, number of bits used to represent sound amplitude. The examiner loves asking this, sound amplitude. They usually again and again ask either sound sampling resolution or bit depth or their favorite sampling rate, which many students, including me myself, used to always get confused with what is the difference between whether it's the definition I memorize, whether that is of sampling resolution or sampling rate. But from rate, you guys should know that rate always refers to number of times a thing has happened. Like the rate of, let's say, me completing the work would be completing 10 tasks in 1 hour. That's rate. So by rate, just remember that it is how many times a sound sample or something has taken place. So sampling rate basically refers to the number of samples, the number of sound samples taken per second, taken per second. Now, this is something very important again, because the larger the sampling rate, the better the sound quality would be. So like, for example, if you use 16-bit sampling rate, it would be a much better quality than using, let's say, a 4-bit one. So the larger the sampling rate, the larger or the better would be your, what do we call it? Sound quality. And by sampling rate, I mean the way we took these samples. Here we took it once. Okay. Now this isn't in the course, and this was something which I always so used to get confused with. So just ignore this diagram. This was for your own understanding. From this chapter, what you guys need to know are these two definitions: sampling rate, sampling resolutions, what the sound is basically about. Like, you guys should know generally about sound and this amplitude of stuff. And now here comes the important thing. How does a computer store a file? How do the computer stores the sound file? The sound file. So firstly, step number one, this is usually a 3-mark question which the examiner tests a lot. The amplitude, it's either this or it's like how do you store the bitmap image, which we discussed earlier. The first thing is the amplitude of the sound wave is determined of the sound wave. Okay, so I just disconnected. I don't know why, but let's start again. Okay, Asad, could you please confirm if the screen is visible and that I just disconnected a second ago? Or did you miss a lot of content? Could you please just give me a message? Okay, okay. Let's begin from where I left. So basically, I was talking that you need to know these steps for how does a computer stores the sound file. This is something really, really important. And so the first thing, the amplitude of the sound wave is detected at set intervals. At set intervals. By set intervals, I mean, like in the above diagram, we discussed how, like, let me go again. So you see this specific point is one interval. This might be like point number 1. This is point number 2. This is point number 3. This is 4, 5. And so at each interval, we are recognizing and measuring what's the amplitude. And so we firstly get to know the amplitude, after which we then, the second step basically is we give an approximate, pen color is not good. We give an approximate representation of the sound wave. Representation of sound wave. By this, I mean basically the computer makes some sort of adjustment, like if the amplitude is of 12 hertz, not hertz, 12 units, let's say, 12 units. So the computer adjusts it and gives it a close value, approximate value, let's say 11 units for the computer. And then the computer converts this 11 units into binary digits. And so the sound wave in the third step, sound wave, this 11 units one, the sound waves are basically encoded as a series of binary digit. And so in a step like this, your computer converts this analog data, analog up here in step number 1, to digital in step number 3. That is everything you need to know about sound waves. And just a small part, yes, one thing has been left. Wait a minute, which is really important. Just 1 second. And I would just take the picture of that just to simplify things. Yeah, wait, I would take your question in a second. Okay, okay, yes, sure. I would explain it. Just 1 second. Let me copy this. Okay, so the second point. Yes, so the second point, basically, in the past, I told you that we have, like, let's say a table like this, right? In which we have a wave moving like this, and let's say like this. Now, this isn't a table, to be honest. This is a graph. You have values 1, 2, 3, 4, 5, up to whatever. And these values are known as bit depth or the resolution. And then we have also numbers up here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what do? We basically check that at position number 1, what's the amplitude of the sound file? It is 3. Okay, we write down 3 first. 3 is for the first beat, let's say first vocal or whatever the first sound is. Then at position number 2, the amplitude is one unit. So we write 1 for the second. And so on, we like convert it. Basically, the second step says that we convert each of this wave. Like you see, at some points, the amplitude is really high, and then at other points, it's really low. And so basically, at different intervals, at different time, when we basically see when is the wave or the sound at its maximum, what do we call it, volume, and so we measure that. Then we see, okay, the volume is dropping, so that would be obviously at a different interval. Then it's again increasing, again a different interval, and so on like that. So this is basically so in other words, in the simple terms, we are basically measuring the amplitude or the bit depth of the waves at different time. Now, this entire wave is of an audio of 10 seconds. So at second number 1, the amplitude was 3. At second number, let's say 9, the amplitude was 2. So it differs, right? If we don't give this an approximate representation at different intervals, this would mean that we have a same wave of the same sound. But you see, always volumes go up and down. And so, like, it's that concept. Okay, that's great. And then the third point basically refers to you converting those binary amplitudes, those amplitude values into binary digits. And now, the last thing of the entire chapter, what are some of the pros and cons of having a large bit what do we call it? Sorry, sampling rate, large sampling rate, and large resolution. Large resolution. By large resolution, I also mean large bit depth. It's the same thing. And so the benefits are basically that you have a larger dynamic range, there is a better sound quality and less sound distortion, which means that your audio isn't, it's like very clear, there is no background noise or stuff like that. But on the other side, you have cons, and those cons are that your size is much greater. If you use, let's say, 10 bits, so obviously your file would also be close to 10 bits. But on the other hand, if you're using 100 bits, 1000 bits, let's say, as the sampling resolution, so obviously that would refer to a much larger file size. Then apart from that, in computer science, know that if we are discussing stuff like where we have larger file size and smaller file size, you could also discuss stuff like it takes longer to transmit or download the sound files, or it takes longer to upload or share those file sizes. It's the same thing. And then the third point requires greater processing power. By this, I mean, in the similar way, in those diagram, you see, if we make a wave like this, if I do it from 0 to 5, the computer might be able to do it in 10 seconds. But if I do it till 1005, obviously the waves would be such larger, and then converting and calculating all those data and giving it a value, that would be requiring a lot of much more power. And because of that, small editing and small sound stuff, that usually takes less time. But if you do it in a studio where you have a lot of instruments, a lot of vocals, a lot of people speaking at once, and you combine all that, that takes a lot of time, because you have a very very high representation and stuff like that. So this is the entire sound chapter. Apart from this, you have one very minor thing left, which is which isn't that, like, it's like a really really easy thing. And they say that a recording editing software has several features. List some of the features. So like features of editing software. So you just need to know that you could, like, let's say, edit the or start or end part. You could delete a part of the video, delete a part of the sample, let's say part of sample. Then you could, if for the sound, we could alter the frequency and amplitude. Like as I mentioned, when I'm recording my classes, after that, when I edit them, there is an option to reduce background noise, and that is basically you reduce the amplitude of the voice which is like in from the background and stuff like that. And then you could do this fade in and fade out, fade in and fade out reference to, you might have seen these transitions where you have this intro and then at the end you just like vanish into something like blackish screen and stuff like that. Those are fade in and fade out features. Yeah, exactly. All those features. It's like a common sense question. Everyone knows. If I tell you, tell me what could video editing software do? You know, you could cut the part, you could edit the starting, you could edit the ending part, you could add, or perhaps in the computer science terminology, you could merge different videos or samples, and you could also, let's say, combine combine various sounds like if I'm recording my recording like sorry my what I'm speaking at the class, and then later on I want to add it to my recording with a background sound, so I could do all that at the same time. My recording, like me speaking, basically me speaking followed by a background speaking, followed by the background sound, and then at the top we have the class recording. So we could do all this at once. And these are like some of the common features of not recording, editing software. And with that, our chapter, not the chapter, we have a very minor part about the file compression left, which we would be discussing in the next class. The class was supposed to be not this long, but we just went with the flow. And so yes, we did two of the very important topics. These are something which usually get tested, especially for the sound and vector graphics thing. And I've also seen some question, not those long question, but a few questions which are about this editing software. So that's all for today. If you guys enjoyed, do let me know. If you are watching the recording, don't forget to subscribe the channel and like the video.